Good day, everyone. Welcome to the Certified Math Majors channel. Now, in today's video, I will teach you a shorter way on how to find the infinite limits of rational algebraic functions. Now, if you look at these four examples here, all of these are rational algebraic functions, and then their limits are actually set at infinity. So, for those who are taking up calculus, one would immediately think of using the L'Hopital's rule, but there is actually a shorter way of finding the infinite limits of rational algebraic functions without using the L'Hopital's rule. So let's go to the rules. Now, these are the rules here. So if you have the degree of the numerator is greater than the degree of the denominator, your answer will always be infinity. If the degree of the numerator is less than the degree of the denominator, then the answer will be 0. And then if the degree of the numerator is equals to the degree of the denominator, then the answer will be the leading coefficient of the numerator over the leading coefficient of the denominator. So let's use these rules to answer these examples. So the first example is you have the limit of 3x to the fifth minus 4x squared plus 3x minus 10 all over x squared plus 7x minus 1 as x approaches infinity. So if you notice, the degree, we're going to look at the highest exponent. So degree of the numerator is 5, and then the degree of the denominator is 2. So the degree of the numerator is greater than the degree of the denominator. So therefore, your answer here is infinity. Now, number 2, limit of 7x cubed minus 4x squared minus 5x plus 4 all over 5x to the 7th plus 3x minus 1 as x approaches infinity. So, degree of the numerator, the highest exponent, it's 3. Highest exponent of the denominator is 4. So the degree of the numerator is now less than the degree of the denominator, and then the answer should be 0. So therefore the answer here is 0. Next, the third one, you have limit of 11x to the fourth plus 5x squared minus x minus 10 all over 2x to the fourth minus 5x plus 23 as x approaches infinity. So the degree of the numerator is 4 because that's the highest exponent. The degree of the denominator is also 4 because the highest exponent is 4. So the degree of the numerator is equal to the degree of the denominator. So the answer is the leading coefficient of the numerator over the leading coefficient of the denominator. So when we say leading coefficient, it's the coefficient of the term with the highest exponent. So in the numerator, highest exponent is 4, coefficient is 11, so leading coefficient is 11 over leading coefficient of the denominator. Again, that's the coefficient of the highest exponent. Highest exponent is 4, coefficient is 2, so therefore leading coefficient is 2. Answer is 11 over 2. Next. Fourth example, you have the square root of 3x to the fourth minus 3x cubed plus 11x minus 22 all over 5x squared plus 12x plus 3. Now, at the first look at it, you can see that highest exponent is 4 in the numerator. But remember, there is a square root symbol, so you still get the square root of x to the fourth, so this becomes x squared. So after getting the square root, that becomes x squared, and then the denominator is x squared as well. So what happens now is that the degree of the numerator is now equal to the degree of the denominator. So what happens now is we use this formula here, leading coefficient of the numerator over the leading coefficient of the denominator. So leading coefficient, again, exponent of the coefficient of the term having the highest exponent. Now, this is x to the fourth. But remember, we are getting the square root. So, square root of 3 is just square root of 3 over, then leading coefficient of the denominator, highest exponent is 2, coefficient is 5. So, therefore, this is square root of 3 over 5. And that is your answer. So that's all for this video. I hope you have learned something. So don't forget to like and subscribe to our channel for you to get updated on our next videos. Thank you so much and enjoy learning.